Hey guys, have your notes here for 4-5 day 3, and this is really cool. This is one of my favorite. I don't know. I'm not a huge fan of trig graphing, but this is probably my favorite day of all the trig graphing. I get to be a little. Okay, so you know how some of you like to be a little bit weird? This is kind of your chance to be a little bit weird. So, what we're going to do is backwards from what we did previously. In the last section of notes, we looked at an equation. We pulled out information. We pulled out the amplitude. We pulled out the B value. We pulled out the vertical shift. Well, today we're going to go backwards. Today we have all that information, and now we're going to put it into an equation. We build the equation based off the information that we have. So, for the example outside the box, I'm not sure why it's up there, but there's an example up there, and it says, hey, make an equation of a sine graph. So I'm going to start my equation with a y equals, because an equation has to have an equal sign. And it's going to be a sine graph, so I'm going to have the SIN abbreviation, and I'm going to have an x in it. Now, I wonder if there's an A out front. I wonder if there's a B in front of the X. I wonder if there's a horizontal shift that goes with the X that might require a set of parentheses around the X. And then I wonder if there's a vertical shift that's going to be hanging off the end up here. So let's find out. The amplitude is 4. I need a 4 out in front. The period is pi. Now, be careful. The period is pi. This is not the B value. This is not the B value. We don't put pi there. That's not the B value. We've got to figure out what the B value is. So, in the last set of notes, we knew the B value and we used the little equation to figure out the period. Well, we're going to do this. We're going to use the same equation. Remember how the equation is period equals 2 pi over b? Remember that? And at that point, we knew b, so we put b there. Do we know b? We don't know b. We know p for period. That's what we know. So this is going to go here. And we're going to solve for b. I go pi equals 2 pi divided by b. Many of you automatically know what b is. What do I have to divide this by so that I get pi? 2. B is 2. Now, time out for a second. What if you didn't know that? There's a way for you to figure it out. You can solve that equation if you couldn't come up with 2 in your head. Not a big deal. Watch, here I go. And if you know how to solve this in your head, just kind of skip forward a little bit in the video. So what I'm going to do, if you couldn't come up with what B was, I'm going to turn this into a fraction. I'm going to cross multiply. And I get 2 pi times 1 equals pi times b. I'm solving for b. So divide both sides by pi, and they cancel. Divide both sides by pi, and they cancel. And I'm left with b equals 2. Alrighty, so b equals 2. I put a 2 in front of the x. That's all that's going on. Now, if you want to, you can put parentheses around the 2x, but multiplication, according to order of operations, you would do multiplication first anyway, so you don't have to put parentheses around the 2x, but if you like them, you can put them there. Okay, let's go on. Let's do a couple more. Next one, cosine graph. Y equals COS, and there's going to be an X in there. Cosine graph. Amplitude is 1. You can put a 1 out front or you can not. It's up to you. Reflect over x-axis. Okay, this is not optional. You need a negative out in front. Phase shift is pi over 4. This is a horizontal shift. And here's the thing. When we describe shifts verbally, we're talking about which way they go. There's no weirdness going on. So when I talk about this phase shift verbally, there's a shift of positive pi over 4. Which direction? It's a shift in the positive direction. That's what this says. Here's a shift in the positive direction. How do you put that into an equation? How do you put a shift in the positive direction into an equation? You do this. Now, you need parentheses. Okay? This described a shift in the positive direction, so we have to do this to it when it goes in the equation. Okay, so I've got that. Frequency is 1. You know what that means? Frequency is 1. That means that B is 1. B is our frequency. That's what B represents. So you need a 1 in front of the X. You can put it out there or you can not. And that's it. We're finished with that one. Next one, cosine graph. Y equals cosine. There's going to be an X in there. The amplitude is 2. Got to have it. Phase shift. So this is talking about a phase shift in the negative direction. This is verbally telling us which way it's going. How do you translate that and put it into an equation? You're going to do this. This represents a shift in the negative direction. And this matches the verbal description. So you're going to have parentheses around that. Okay, got that. The frequency is 1, so B is 1. You can put it there or you can not. And, wow, got a little crazy with my circles here. So the amplitude is 2, we got that. And it's going up 4, plus 4, hanging off at the end. Next one, sine graph. Y equals sine. There's got to be an X in there. The amplitude is 5. You need that. Reflect over the x-axis. You need that. The period is 2 pi over 3 and it goes down 2. Okay, so you know what? I'm going to go ahead and take care of that one. Now let's work on this. The period is 2 pi over 3. That's going to take some work. Remember the little formula that we use? Do we know B? No, we want to. Do we know P? Yes. P stands for period. It's 2 pi over 3. Replace that. So I got 2 pi over 3 equals 2 pi over B. Right? I subbed in 2 pi over 3. Was it 2 pi over 3? Yes, 2 pi over 3. Equals, copied it. Guess what B is? Good job. B's 3. So, you need a 3 there. And you don't have to have parentheses. I think I'll scoot that in a little bit closer. You don't have to have parentheses. This is attached to the X. That's hanging off at the end. If it makes you feel better, put them. If that makes you feel better, you can put them there. Next one, sine graph, y equals sin. We're going to need an x. Our amplitude is 1. You can put it or not. Period is 4 pi. It's 2 pi over b. Remember, I'm going to use that little formula. I'm going to sub in. I know what p is. I'm going to sub it in. Goes right there. This one's a little tough. Can be. Some of you mathy people are like, ooh, I know what b is. I'm going to put it in my equation and forward the video. And that's fine. Others, it's going to take you a little bit of work to figure out what b is. No problem. We can do that. So, I'm going to turn that side into a fraction. I'm going to cross multiply. 2 pi times 1 equals 4 pi times b. Remember, we're trying to figure out what b is. So you need to get rid of this that's attached to the b. Get rid of the 4 pi. And I do that by dividing by 4 pi. The pi's cancel, and I'm left with b equals 2 over 4, 1/2. Okay, so b, 1/2, goes in front of the x. And we've got a phase shift of 3. Positive direction, 3. Now, you need parentheses because this isn't a vertical shift. This is still part of our x. It's a horizontal shift. You need parentheses. However, those are wrong. If you put them there, you're telling whoever looks at your paper, hey, you've got a factor. So whoever looks at your paper to determine what b is and what the phase shift is, you know what they're going to do? They're going to pull the 1/2 off of the x, and they're going to pull the 1/2 off of the 3. And they're going to say, you've got a phase shift of 3/2. No, you don't. You got a phase shift of 3. You're the one writing the equation. You put your parentheses in the appropriate place. You putting your parentheses there, does that say I have a phase shift of 3 and b is 1/2? Because remember, you can't talk about phase shifts until it's in factored form. So write it in factored form. Alrighty, so you've got a little bit of experience writing equations. Here's where it gets fun. It says, these say, here's a graph. Find 2 equations, one for sine and one for cosine. Well, I see a sine equation. I see a sine graph. Don't you see a sine graph? I see a sine graph that starts here. Up 1, hit. Down 1, hit. I see a sine graph. So, let's talk about that for a minute. What's our amplitude? It's 1. It goes up 1 and down 1. What's the period? Period's 2 pi. Which means b is 1. Those go together. If the period's 2 pi, b is 1. Don't believe me? Do that little formula. There's no left shifting, there's no right shifting, there's no up shifting, down shifting. It's just a sine equation. So I'm going to write a sine equation. Here I go. Y equals sine x. Now, look away for a minute. Come back to it. Can you, and remember this goes on forever, right? It's got arrows on the end. What if this were a cosine graph? Where would it start? Cosine graphs don't start at the origin. Cosine graphs start at a height of 1. I need you to find on this graph where it has a height of 1. Now, starting there, draw one complete cycle of sine. No, sorry. Starting there, draw one complete cycle of cosine. Up 1, hit, down 1, hit, up 1. It could be a sine, it could be a cosine graph that has just been moved over a small amount. I think it's like, watch. I think somebody took a normal cosine graph and moved it right pi over 2. Amplitude is still 1. The period is still 2 pi. So from here to where it ends, like extending it, it's still 2 pi. So same as here, same as here. The only difference in the two graphs is a horizontal shift. That's the only difference. So let's write our equation. Y equals same amplitude, same b value, cosine x, right pi over 2. You need parentheses. Oh, no, sorry. sorry. Hold on. Right pi over 2. Okay, let's keep going. So on this one, I want to point out that because we're gonna encounter one in a minute that the midline's going to move. I want to point out that this is the middle of the graph. Middle vertically. So from here, it goes up 3 and down 3. This is still the middle. From the middle, it has like a height of 3 in each direction. So I believe that the amplitude in this case is 3. Now, what do you see first? Do you see sine when you look at this, or do you see cosine? I think we're going to get 50-50 on this. I think some of you are going to say, oh, it starts at 0, or it starts at the origin, I see a sine graph. And others are going to see these two peaks. They just jump out at you. You're going to be like, oh, no, I see cosine. I see cosine from there to there. And some others are going to say, well, I see sine from there to there. You're both right. So I'll start with sine first. I see sine starting here, up 3, middle, down 3, back to the middle, stop. I drew one cycle. How long did it take me? That's how long it took me. Figure out B. Formula. sub it in. And here's what's cool. We can go ahead and make our sine equation. It's not been shifted left or right. It starts where it's supposed to. It has an amplitude of 3. The only difference is it has a b value of 2. And all of this information stays the same when I write my cosine. Not ready to write my cosine yet, but it's all going to stay the same when I do. So here I go. Y equals amplitude of 3 sine b, come on, b times x. So the amplitude for sine is going to be the same when I do amplitude on cosine. The b value is going to be the same for cosine. The only difference is I have to find a horizontal shift to make that cosine. So I'm going to erase that, and I'm going to kind of highlight a cosine curve. So cosine would start up here, hit, down, hit, end. How is that different from a normal cosine curve? Well, a normal cosine curve with an amplitude of 3 would look like that. It would start at 3 up and hit and go again. How is the black function different than the purple function? It had to scoot over, in order to match up, it had to scoot over this far. How far is that? Well, this is pi over 2, so that must be pi over 4. So for cosine, it had to go right pi over 4. So let's make our cosine equation. Y equals same amplitude, cosine, same b value, and we have to say right pi over 4. Make sure you put your parentheses in the proper location. Have I mentioned that the only difference between your two equations is going to be a horizontal shift? Have I said that like 2 or 3 times? The amplitude is going to be the same. The b value is going to be the same. If there is a vertical shift involved, it will be the same. The only difference is between the sine and cosine equation is there's going to be a horizontal shift. Also, let me throw this in there, and I don't want to like confuse you or try to create try to get you to use a shortcut if you're not quite understanding. Let me throw this in there for you mathy people who are really picking up on this. Do you remember how yesterday, no, 2 videos ago, I told you that B represents the frequency? Now, what does frequency mean? Frequency is how many cycles do you see in a 2 pi range? That's B. You don't have to do any math. Just how many do you see? Count them from 0 to 2 pi. So ready? From 0 to 2 pi, how many sine cycles do you see? 1. B is 1. Well, we knew that already. Next one. From 0 to 2 pi, how many sine cycles do you see? I see 2. B is 2. You can always go look at the period for 1 cycle and do your little formula, or you can recall that B represents frequency. Frequency is how many times do you see a cycle in a 2 pi period. Next one. What do you see? I see cosine. I see cosine. But I need both. Now, here's what happens. Some people are going to say, oh, but wait, cosine normally starts at 1. This must have an amplitude of 2. Wrong. Where's the middle? Where is the middle of this graph? The middle of the graph is right there. Do you see how what is normally the middle of the graph is now up here? Because cosine always goes above the middle and below the middle. So the middle has to be here. Now, what's the amplitude? Once you've identified what the middle is, now you're going to have to say that the amplitude is just 1. Because from the middle, it only goes up 1. From the middle, it only goes down 1. So the amplitude is 1. And what's the period? How long does it take for you to see one complete cycle? So the period is 2 pi, which means B is 1. They go together. Also, some of you are going to say, oh, well, I see in a 2 pi period the frequency, B, the frequency is 1. So amplitude is 1, B is 1, everything's normal, except it's moved up 1. So for my cosine graph, y equals cosine x, but the midline has been moved up 1. This will be the same for sine. The amplitude will be the same. B will be the same. The upshift will be the same. The only difference in the two equations is a horizontal shift. I've said that like 5 times now. Oops. Okay, let's find a cosine equation. Ready? Cosine starts on the midline and heads up. Let me remind you. Cosine starts on the midline and it heads in the positive direction. Where does the graph, the black function, touch the midline and head up? Well, here it touches, but it heads down. Here it touches, but it heads up. So you could say that you see your sine graph start here. Ready? Middle, up 1, middle, down 1, middle. It's a sine graph. How far over has it gone? Well, from normal, how far would we have to scoot it? We would have to scoot it this far. We would have to scoot it 1 pi and a half more. So I could say, right, 1.5, 3 pi over 2 for sine. Okay, so first of all, it's going to be the same. There's going to be an x in there. And I have to go right 3 pi over 2. Right 3 pi over 2, put parentheses around it. Okay? But maybe you didn't see it there. Some of you, let me erase that. I can't even concentrate if that's still there. Okay, so there's the midline. Some of you said, no, I see sine starting back here. Because if we just extended this a little bit back here, Can't we just say it starts there? Can we say it starts here and goes up, middle, down, middle? There. Done. Finished. One cycle. Of course you can. How much of a shift is that? Well, from the normal place to start, it would have to go left. How far is that? Pi over 2. So maybe your equation says left pi over 2. That's okay. Plus pi over 2. That's acceptable. And I'm going to have that as an option on my answer key for those of you that see it starting there. Did anybody see it starting here? Flipped upside down. Middle, down 1 middle, up 1 middle. That's the sine graph just flipped upside down. So you could, oh, no, there's still a shift there. There's still a shift right, pi over 2, so minus pi over 2, but with a flip out in front. So many possibilities. It's like I said, this is your time to be a little different. Whew, okay, last one. Well, first of all, the middle, here's the middle. How far up, down does it go from the middle? 2. Amplitude is 2. That's going to be the same for sine and for cosine. The middle is on the axis, so there has not been any upshift or downshift. I think we've got to figure out the period of the graphs that will help us find B, as well as any shifting that's going on. So it's a little bit of a challenge. But I see sine first. I see start here and end here. How much of a distance is that? If it had started here and ended here, would you say that would be normal? Like a 2 pi period? I think you would. If it started here and ended here, that would be normal. Okay, but it didn't. It started left. How much? How much left? 1 pi over 3. It started 1 pi over 3 early. Where did it finish? Well, 2 pi would be 6 pi over 3. So it finished 1 pi over 3 early. That's 2 pi. That's 2 pi. So the period is 2 pi. You know what that means? It means B is 1 for both equations. So all you have to do is figure out the shifts. Well, I've already talked about the sine shift. The sine shift went left pi over 3. Okay, well that's easy. Sine left pi over 3. Put parentheses around it because that's part of horizontal. Cosine, well, let's see. I gotta change the way I'm seeing this. Let's go from peak to peak. So cosine here. Oops, missed. To here. Now, I've already got the period of the graph. Like that, I already know that. Don't do that again. Doesn't cosine normally start on the y-axis? Does this one? Nope. Well, how far right is it from where it's supposed to be? It's this far. It's this far right from where it's supposed to be. This far? No, that's too far. That's pi over 3. I need half of that, pi over 6. So cosine right pi over 6. Okay? And remember, amplitude's the same. This was a plus because I saw the sine starting here, and this was a minus because I saw the cosine starting there. But guys, your alls might be different. Some of you might have seen the sine graph. It's kind of weird, but some of you might have seen the sine graph starting here and heading out like that. Okay. Some of you might have seen the cosine graph starting here and being upside down. Okay. Just make sure to include the shift. Whew. It's a pretty long shift. Make sure to include the shift and the flip. Okay, now I know I'm pretty long, but I really want to show you one more thing on how to check to see if you think you've got the right answers. Yep, you can look at the answer key. But some of you, I've noticed, are like super into your graphing calculator. Like the only time you put your graphing calculator away is when I say, you can't use this on this test. And then you're like, oh. Even though leading up to the test, I'm always like, scientific, 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 scientific. You've got that graphing calculator on your desk every day. I want to show you something cool. So I'm going to take my graphing calculator and I'm going to show you how to check probably just this first one. And I'm checking the ones that we wrote 2 equations on. So I'm going to switch screens. There we go. There we go. Got my graphing calculator here. All right. So, on example 1, I know you probably can't see this. On example 1, I want to set up my graphing calculator the way that this graph is set up on example 1. So, on this example, my x's go from 0 to 2 pi, and my y's basically go from -1 to +1. So, here's what I'm going to do. I'm going to turn on my graphing calculator. First, let's go to mode, and let's make sure we're in radian mode. So right here, make sure you're in radian mode, because our x's are in radians. And then I'm going to go to my window. I want my x-min, I want my smallest x value to be 0, and then arrow down. X-max, well, what's the last value that you see on your x-axis? I see 2 pi. I'm going to type in 2 pi, like literally, 2 and pi. See it? Watch, when I arrow down, it accepts it in decimal form. It's kind of cool. X scale, what are we counting by on our x-axis? X scale, well, I think we're counting by 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. We're counting by pi over 2. That's what I want my scale to be. So scale, I'm going to type pi over 2. Okay, and then it'll change it to decimal form. Okay. Y's, let's go from -1 to +1. -1, +1. Okay. Ready? Now, go to y equals, clear out anything that's already there. I'm going to type in sine x. Sine x. And just for fun, I'll graph it. Does this graph match what you see on your notes? It does. I wonder if the other equation that we wrote, the cosine equation, I wonder if the cosine equation will look like this. Now, here's what's cool. If you've got a cool graphing calculator, the one that graphs in color, they are awesome. And what you'll see is, if you put them, hang on, let's just go ahead and put them both there. So now I want them to do both. I want it to do both equations, so I'm going to retype it. So I'm going to put sine x in my first one, sine x, close. And I'm going to go down, I'm going to put cosine parentheses x minus pi over 2. Close parentheses. Now, here's what's going to happen. I'm going to hit graph. And it's going to graph sine x. So you're going to see it do this. And then, if my second equation is correct, you won't see anything happen. Because after it graphs sine x, it's going to graph cosine x minus pi over 2 right on top of it. You might see it getting a little bit darker. If you've got a cool graphing calculator, it'll go like red, and then your next color might be blue. And you'll see it trace right on top of it. So let's see what happens. Sine x. Yeah. It went right on top of it. If one of our equations was wrong, they would not have matched up. So that's a good way to check yourself, is on any of these that we just did where we made two equations, if you want to mess around on your graphing calculators, and I know some of you like to do that, graph both of them and make sure they trace on top of each other. Because if you see them make two different graphs, you've done something wrong. Okay, I've taken up a lot of your time. I'm sorry. I hope you kind of enjoy this. Good luck.